morning, interwebs, especially those running APIs. If you've missed every show thus far, this is one you don't want to miss if you've got an API running, because this show covers API security and their vulnerabilities. If we haven't met yet, I'm Alyssa Knight, and you're listening to Aite Radio, where we discuss everything hot and trending in the world of cybersecurity. Joining me today is a very special guest, Dmitry Sotnikov from 42 Crunch. No, it's not a fitness gym, it's an API security company on a mission to secure the world's APIs. Today we'll discuss the company, what the heck APIs are, and API security gateways, how recent victims of API security breaches like the Marriott and T-Mobile were compromised, and how you, the CISO, can prevent it. Dmitry, thanks for being a guest on our show. Let's nerd out.
Thanks, Alyssa. Sounds like a great plan.
Awesome. So who are you? Who is Dmitry? And did I completely massacre your last name? Is it Sotnikov?
Yeah, you did it great. Absolutely. Okay, so I'm Dmitry Sotnikov. I work for 42 Crunch. It's a startup. We're about 3 years old. We do API security. And I'm in charge of a bunch of different things within that startup, including our API Security.io community, our work with partners, and our cloud platform.
So when you say you work with partners, who typically partners with 42 Crunch? Would these be like third-party technologies that you guys interface with over API? Or what would a partner be classified as in your world?
Yeah, so some of these would be different vendors who are in the API space, API development space, developer space, or security space, and we make sure that our products work better together and complement each other, because it's rarely that a single product, a single company, a single technology can do everything that the market needs.
Agreed. Yeah. And so correct me if I'm wrong. That would be, for example, you're referring to API development environments or ADEs, correct? That sort of thing.
So yes, that would include ADEs, IDEs, or tools in the DevOps space, continuous integration, continuous delivery, and so on.
Now, I keep me honest here, but I do believe your product actually does 3 things, not just one. It's not a one-trick pony. It allows developers to write more secure code when they're developing APIs. So it will actually analyze the code as they're writing it, looking for vulnerabilities, and help the developer in actually hardening that code. And then it will allow the developer to import that swagger, if I got the terminology right, into the platform, and it will analyze that code once it's written and look for vulnerabilities. And then the third is more of a dynamic sort of analysis where you can actually point your API traffic at your platform, and it will actually analyze the traffic before it hits the customer's API, sort of filtering it or securing the traffic and looking for bad things. Is that correct? And I believe I'm missing a fourth. There's actually 4 capabilities, and you can actually target a URL and have it scan the URL for vulnerabilities. Is all of that correct?
Yes, that's all of it correct. So typically they would be in a different sequence. So typically, again, it would start with developers. We are big proponents of the DevOps, DevSecOps approach and shift left, and that security needs to start from API design and development. So we would help developers right within their developer environment or within their CI/CD pipeline analyze their code, do static analysis. We run about 200 different checks and give them a list of all the potential vulnerabilities, exploit scenarios, how to fix them, and so on. So that's the first step. Then developers follow those recommendations, tighten their APIs, and commit the code. The code passes the checks, gets accepted, gets built. Second stage is indeed, like you mentioned, dynamic scan. Run that API, run that code from developers, and see if the code behavior matches the intent and matches the API contract. And then finally, the API firewall, something you can put in line of traffic, in front of your API, to make sure that the contract is enforced and attacks don't get to your code.
Very cool. So just so we break down terminology for anyone in our audience who doesn't know what an API is, or even an API contract. An API contract is really the terms of the agreement between the backend API and the client. Let's say, for example, a mobile app. So the intent of what the client should be able to access and do and perform, and what it's not allowed to do. Sort of like a rules of engagement, right? So what the client is allowed to do and not allowed to do with the backend API server, that is an API contract, correct?
Yes, and we're actually lucky that in our industry today, there is a pretty much one standard way of describing APIs. And like you mentioned, the security that the API needs, and the paths, the verbs, the parameters, the responses, and so on. There's what you already mentioned and referred to as Swagger. Now the official term these days is Open API format. And it's an industry initiative under Linux Foundation with companies like 42 Crunch, but also Google, Microsoft, eBay, and APG, MuleSoft, and so on, being all behind one single standard that describes all that.
Okay. Just so our audience knows, I've been doing security for about 2 decades, right? I'm going into 20 years now. And even just like some of the terminology is just mind-boggling. It's almost like a different language, JSON and all this other. I mean, it's going to make sense for, Swagger. It's going to make sense for people who are actually developers. But I think for the penetration tester, for the red teams, for the blue teams, a lot of this may be very foreign. So a lot of people that I've spoken to, in my experience, really don't understand the distinction between a web app and an API, right? Like, is an API a web page? Is it a website? Why don't we just sort of move back to the beginning and backpedal and have you explain to our audience what the heck an API is? Is it a web page? What's it have to do with mobile apps? What is an API? There's REST APIs, and just if you can just kind of help our audience understand and demystify what APIs are, I think that will really help them.
Yeah, that sounds good. So basically, API is just application programmable interface, right? So basically, it's a way for different components, different systems to talk to each other programmatically. And APIs can be different kinds of APIs, but as you mentioned, right now, basically one of the ways that the APIs, one of the formats of the APIs, REST APIs, sort of won the battle and became very prevalent. And so that's not the only way that APIs can exist, but that's definitely the most popular ones. And whenever you see a URL in your browser that sort of has some path, some slashes, and then it would have maybe a question mark, and then some sort of parameter name equals some sort of value. That's sort of the way that REST APIs look. And they became very popular, especially because it was very easy for people and for any web developers to understand the way that they function, and they could, even within a browser, just type a path and get some sort of response within the browser. So REST APIs are very, very similar to regular browser URL and regular website responses. And that's why they became so popular and so prevalent.
What you're saying is if we were to just apply that to a use case, if I were writing a mobile app or developing a mobile app, for example, and let's say I wanted to create a mobile app for my restaurant, and I want to be able to give people that are wanting to come eat at my restaurant, directions on how to get there from within my mobile app. I could use, for example, Google's APIs and their map functionality to actually put that navigation or capability or that map within my mobile app, and I would use Google's API servers to do that. Correct. So in many ways, it's really not just a web page that we understand with pretty graphics and and HTML, but more along lines the backend data behind it, and providing that backend data that may be in a database or maybe stored somewhere to a client interface like a mobile app. Correct?
Yes, that's correct. Right. So you could just embed like a Google Maps widget within your page, but then if you wanted to actually get the data, for example, whatever turn-by-turn instructions, or if you wanted to have some functionality to say send a text message to your customers within your app, most likely you would not be implementing your own navigation system or implementing your own gateway to be sending short text messages to phones, but you would use an API from a third party to do that, just to invoke that functionality and get some information from that other service.
Now, are APIs typically only found in mobile apps, or what are other use cases? Obviously, I've done quite a bit in penetration testing connected cars. Have you ever seen electronic control units or head units, for example, within a vehicle, like IoT devices leveraging APIs?
Yeah, absolutely. So APIs are now everywhere. There was a recent statistics published by Akamai, I think a couple months ago, and Akamai are obviously one of the popular CDN systems out there, and a lot of traffic, a lot of web traffic on the internet is going through Akamai, and so they've looked at all the data and all the traffic going through them. And they are claiming that 83% of all traffic that Akamai is seeing is actually API traffic.
Oh my God!
So most of that web traffic on the web today is actually not sort of website to human traffic, but that's some API traffic that eventually might or might not be rendered by some sort of an application. But that's web API traffic.
Oh my God! So this is a thing. Like
exactly.
This is a thing. We're here. This is not futuristic stuff. This is happening now, and it's more than 80% of the. Holy cow! Okay, so how is this API protected, right? So we're the community of listeners in this show. They're security engineers, they're CISOs. Most likely they work at a bank or financial institution or whatever, and I'm sure that company has an API server. Obviously, it's not just financial institutions or fintech, but pretty much every company now these days probably has an API. So third-party applications can share data and talk to their data. So I'm assuming I can't just send a REST request, a REST client request to someone's API server without having a legitimate account or knowing something, knowing a password. How are APIs protected?
Yeah, so it's a great question. And again, just to make it clear, I think in the examples that we've discussed so far, we were talking about sort of third-party, external, some sort of API servers, but it's obviously a lot more than that, because most of the applications these days, even internal applications, would actually use APIs. Even if you have, maybe your company thinks that you don't have APIs, but most likely you do. And most likely if you have a mobile app, that mobile app would actually have some sort of a backend service, some cloud service that it needs. If you have a web app, most likely you have some sort of a server, some sort of a cloud component running in AWS or another cloud. And then your web page is just talking to that external entity, that backend, and rendering the results. Or if you have an IoT, like you mentioned, again, you want a GPS tracker in the car or something. Most likely, again, that GPS tracker would be controlled by some sort of cloud service, and they would use APIs from each other to communicate. So APIs are more than just some sort of external service. They are also a huge part of the modern architectures. And in the microservices way, architectures, when you are decomposing your application into multiple microservices, when Kubernetes is something, each and every component of your application is talking to another component using APIs. So that's how you get to that 83% of traffic.
Yeah, I mean, smart cities, all obvious. So, okay, let's look at a little bit more terminology here. So, there's API tokens. I believe even separate of that, there's this concept of API secrets. And, or let me know if they're one and the same thing, just get people calling it different things. But API tokens, API secrets, and then just, like tokens in general. I mean, are all those the same thing? And what is an API token?
Right. And so, like you mentioned, when you're invoking some other API, you would want that to be more than just a URL that anyone can hit, right? Because if that API is exposing your customer data or is exposing the functionality of your product, you would want some security. You would not want anyone on the internet to just go and start using it directly.
Right.
So there are different ways that you can do that, right? You could, just like on the web, for example, you could just use basic authentication and just username and password. And you could base 64 encode that and send that with your API request as an HTTP header. So that could be one of the ways. But then you could also do something like you could, for example, just agree on some sort of an API token, API key that you would give to your clients,
like a pre-shared secret.
Like
right?
a pre-shared secret.
Okay.
Right? You would say, okay, you're a partner of ours, or maybe you would tell your mobile app developers. You would say, okay, this is whatever. This is ABCD 1 2 3 4 5. You include that in a header called X API key, and then my backend, each and every time it sees that ABCD 1 2 3 4 as that header, it would assume that yes, you are the legitimate client, and it would respond to your request. And the worst one is when people start putting keys, like API keys, in their URLs. That's by far the worst.
Okay, so actually passing it in the URI.
Yes.
Oh,
The
wow.
URI is the worst, right? Because URIs, anyone can see them, right? Your routers can see them, so you can get them in the network. You can get them in the referrer information if someone was on that site and then went to a different site. So they can leak in the logs and so on. So that's the worst. Headers can be relatively better, especially if you're using HTTPS.
Right. Yeah, I guess I should make a distinction: HTTP header versus the HTTPS. So yeah, definitely, it's hopefully it's TLS encrypted, which I'm assuming is not very common in your experience, or you guys wouldn't be in business, right?
Correct. Yes. Unfortunately, we still every now and then. So, by all means, everyone listening to that show, only use HTTPS. Never ever use HTTP. There's no reason to use HTTP, like none. And unfortunately, that's not the case sometimes. There was just recently Verizon had to patch a lot of their home routers. Because those home routers actually allowed HTTP traffic. They were not enforcing HTTPS for management of the router.
Oh, wow.
And so attackers could actually drop in, get the traffic of you sending commands to your router, and then use that to grab authentication information, grab the keys, and then go and set up your router.
And so you guys have actually seen in instances I'm assuming in pre-sales engagements with customers that they are a lot of the API traffic has just historically not been encrypted. This is actually a thing. It's something a lot of companies are still doing even in 2019.
Exactly. Yes, and even
Wow.
even the bigger ones, like I mentioned,
Wow.
Amazon's Ring doorbell had a similar attack recently when it was not encrypting the traffic from the camera in the security camera in the doorbell, and so someone could spoof it.
Oh my God. That's amazing. So let's talk for a brief moment about I think one of the biggest challenges right now that API security companies are up against is educating the market, right? And that's always, it's the whole first mover advantage is not necessarily a good thing because you have to educate the market on it, right? It's an expensive endeavor. A lot of the market, a lot of the buyers out there don't understand the need for API security. Even with recent headlines like Marriott, even T-Mobile, I believe, was compromised as a result of their API. So what? I think. Correct me if I'm wrong. The big misperception here is really being driven by the product category of API gateways. That there's these solutions out there called API gateways, and it is critical, it is paramount that companies understand that API gateways are not API security gateways. They're not API security solutions. They serve a different function. Their reason for existence was not security. Can you talk about that? The distinction between API gateways and API security gateways?
Yeah, absolutely. I think there are actually two categories of products that made people confused. One is API gateways, API management tools, and the other one is web application firewalls.
Oh, agreed. Yeah, WAFs, definitely.
Yeah, and so on the gateway, so let's start with the API management tools and API gateways. So these, when people started doing web APIs, they wanted to have some sort of experience for their subscribers that would include some sort of a web experience, just like developer portals, so subscribers could come, see the APIs that are available there, read the documentation, get some security in terms of authentication, like be able to request an authentication key and see your key, maybe get some reporting on your API usage, and maybe also get some basic policies, basic throttling, to make sure that no particular customer, no particular subscriber overwhelms the backend by sending too many requests. What else? Some of those also evolved in the integration space, allowing customers to orchestrate APIs and have multiple backends, some sort of, in a way, merged into one API. So that's basically the scope. It's very operational and sort of aiming to enable your subscribers, enable your partners, enable your customers.
More along the lines of a system administration function versus a security administration function.
Correct.
Right.
Correct.
Okay. So when a developer is issuing an API token for authentication, dare I say, even authorization, that key or that token will typically be generated by an API gateway product, correct?
Yes, in most cases.
Okay.
And that makes absolutely a lot of sense, because you don't want each and every developer to do that whole token issuing and the whole OAuth 2.0 implementation and so on. You would want to use some sort of an external product, external service to do that.
Right. Why recreate the wheel?
Exactly.
Sort of thing. Okay. All right. Go on. That makes total sense.
Yeah.
That makes total sense.
And so the problem with these is that they obviously, like these products, they have been developed for those operational purposes, right? So they would not help your developers design their APIs in a secure way. They would not tell developers when they're not following the best practices. They would not tell them, oh, you know what, the way that you've designed your API allows someone to just grab that ID parameter that you're passing as an API parameter and enumerate all the IDs of your users and then retrieve all your data. For those API gateways, it's just fine. Someone is using the APIs. The API is not under a denial of service attack. The API is using legitimate authentication key. So it's all fine from that API gateway perspective, right? That the product does what it's supposed to do. And it's all good, even though you are under attack and your API has not been designed in a secure fashion.
Okay, so that makes sense. It's more, like we said, more of an administration piece. And correct me if I'm wrong, but it will also not do what your product does, which is explain that there's a difference here in the contract and the API contract and what's allowed by the mobile client or the client in general, and what the contract states is allowed or not allowed. Like what the backend API server actually allows and doesn't allow in the code level, and what the contract states.
Yes, that's correct. So yes, API gateways are good. API management tools are good. They are complementary. If you are to share your APIs with someone, by all means, use them. But also use an API security tool to make sure that your APIs have been developed with security in mind, that you know all the APIs that you're exposing, and that you are enforcing not just authentication, but you also are enforcing your contract and security on all the calls.
And Dmitry, I'm sure you've run into situations where a CISO will look at you and say, you know what, Dmitry, I don't understand why I need to buy your product if I have a WAF. I have a web application firewall. I don't really see the need for something like this. We're protected by, whatever WAF technology. Why can't a WAF do this? Why do I need to care about, mobile app shielding? Why do I need to care about, analyzing the code, at the client level to, making sure the contract it matches up with the code? Why not just leave it up to the WAF?
Yeah. So again, I think WAFs actually played. Okay, let me step back. I think that when the world sort of transitioned to REST APIs, that simplicity of REST APIs played a very bad joke on the technology from security perspective, because again, people could see that REST APIs are just something that you can use in the browser, so they assumed that, hey, our web APIs are just web traffic. We'll already have a WAF for our website. We'll just make sure that all our traffic goes through that WAF, and so our APIs would be secure automatically. And that's not the case, because your WAF, even though it sees all the traffic, it has no idea what your API needs and what's the legitimate or not legitimate use of the API, right? So it would see that, hey, there's that traffic coming in. You might be able to configure some blacklisting rules. You might say, okay, if this is a SQL injection signature, then block it. But other than that, again, a WAF has no idea of your API behavior, of the expected API behavior. It doesn't know whether these parameters coming in are within of what your API needs or not. If that JSON payload coming in is something that your API expects, or that's an attack. It has no idea if something starts coming back from your API. Again, there's a bunch of data, some sort of HTML or some sort of a JSON structures coming back. Is that what's expected, or is that data leaking from the API because someone managed to hack it? Web just has no idea of what's the expected behavior and cannot block something that is unexpected.
And it's a topic of discussion right now in security that security without context is not isn't really security at all, because just because the WAF is looking at that traffic, it doesn't necessarily mean that me as a listenite should be getting that data in response to the API request. Am I authorized to see that? The WAF doesn't know that.
Exactly.
Huh. Interesting. So going back to the authentication using, for example, tokens, correct me if I'm wrong, but I believe for security around API, a developer would typically, hopefully, combine both a username and password and an API token issued from an API gateway. But it sounds like the two aren't necessarily tied together. You can have an API that just issues tokens for authentication and doesn't rely on usernames and passwords, or will issue a token and only tie the type of data that person gets or that app gets based on a username and no password, or just a username and password. Correct? It can be all of those things or.
Yeah, so it really depends on the scenario. Like in the, for example, in the microservices world, well, when you have a bunch of your own microservices, your own components just running and talking to each other, you do not need usernames and passwords. You'd rather use something like mutual TLS authentication, when each and every microservice gets its own certificate, and they would only talk to other services that have proper certificates, right? So even if someone intercepts the traffic, or if someone tries to get from outside, as long as they don't have that TLS certificate, the microservice would not even talk to them, right? So
interesting. So that's why in my recent research of these 30 financial mobile apps, I was finding private keys, private certificates in the mobile app. That was one of the things that I was really confused by in my findings, was why am I seeing private certificates here? So you're saying that it actually that a mobile app may actually use both an API token and a certificate, and the API will not talk to that device unless it has that private certificate and the token. Is that a correct statement?
Yes, that's a correct statement. So whenever you have a device, always try to make sure that you don't just authenticate the user, but you authenticate the device. The fact that you could find all of that in the code is obviously bad. It's scary. Right? Yeah. And unfortunately, that's that's not very rare. That happens. However, because devices these days, even the mobile apps and mobile operating systems, they have private storage on the device that the vendors could use instead, and to store their secrets rather than keep them in the code. Same thing is happening in a lot of cloud systems, like, for example, Kubernetes has its own way to store secrets. Operating systems, again, desktop and server operating systems have their own security vaults to store secrets. So by all means, use that. Don't have it in the code.
So it is a perfectly accurate statement to say that there may be use cases where you only need the private certificate and the token to be seen as a legitimate endpoint for the API to give you its data.
Yes. So always look at the scenario, look at the architecture. If it's your own deployment, limit it on put the certificates, but also can you limit it within the network? Can you say that these services only exist in this subnetwork and should not be accessed from another network? Can you limit a set of IP addresses? Can you do some sort of IP whitelisting? If there's a user involved, again, how is that user authenticated? Is there, if you have multiple users, how do you make sure that a particular user can only access data of that user? Again, don't expect that if someone is authenticated, that person will only try to access his or her own data, and they would only change, and they would not change some sort of parameter in the request and get someone else's data instead.
Based on an ID, right? And
based on ID, right? And that's what is called an IDOR attack, insecure direct object reference, when you just trust the client to give you his or her ID rather than someone else's ID. Don't do that.
And doing a black box penetration test, or even a black hat who doesn't really understand the backend API architecture, understand what parameters are expected in the body, what parameters are expected in the header, all they really need to do is set up, for example, something like Burp Suite and proxy between a legitimate login, a legitimate authentication, and really learn just by looking at the traffic, learn what the API expects for parameters, right? So, I mean, even if they weren't looking at the code, let's say it was a pure black box assessment, all they really need to do is look at the traffic to find out what parameters it's using, right?
Exactly, and that's what they would typically do, right? So one thing, obviously, attackers, if there's some sort of mobile app or something, they would try to decompile it and see the code. But they would also just look at the traffic, and it's very easy to do. And they would see what what kind of commands it is sending. And yes, once they see some sort of ID parameter, they would definitely try to change it and see if they can still get response.
I got to tell you, Dmitry, I've been doing podcasting for quite a long time, and this is probably the coolest episode I've ever done. This is a pretty exciting topic. Okay, so there's definitely a problem here. There's definitely, I think, a misunderstanding by industry about, if they have a WAF, then they don't need this. If they have an API gateway, they don't need this. I think you've done a really good job at explaining why. Can you tell me how? So I think we did, kind of cover the common ways APIs are hacked. Typically a black hat will intercept the traffic, interdict that traffic and look at it, or reverse engineer the mobile app, understand how the API works, understand how its authentication works. Sometimes it's just a token. Sometimes it's a token and a certificate. Sometimes it's a token and username and password. But they can quickly figure that out. What should CISOs be looking for in an API security product? So let's say that I'm Alyssa CISO. I'm coming in, hey, Dmitry, I know I need this now. Thanks for helping me understand that. I'm going to look at 3 different API security vendors. What should I be looking for in a product?
First of all, I think a CISO needs to understand well the use cases and what is the current way that APIs are being developed, tested, and used internally. Because you would want to get a product that would fit your current procedures, your current set of technologies and ways. In most cases, APIs exist there for a purpose. They enable your business, right? And developers have to stay agile and have to produce those APIs. You don't want to stop that. You don't want to make everything secure by killing your business, right? So you would want whatever technology you buy to get embedded into the technology that your developers are already using, to make sure that you enable your developers, and then developers can get security audit, security assessment within whatever they are doing, rather than just being stopped and blamed, right? So you want to enable them. That's the first thing. Secondly, I think any product needs to give you visibility into which APIs you have, what's the level of security, and sort of help you as a company do a proper assessment of where you are and where you need to be and how to get there, And so they would need to give you that visibility. And ideally, again, they are standards based. So we've already mentioned Swagger, Open API standard. So being standards based is a good thing. You can again get integrated into other systems and other tools. And finally, whatever your API security product is doing, it needs to be, I guess I should use the word explainable, right? If your API security product is blocking some sort of traffic, then you need to be able, or the product needs to be able to explain why that particular traffic got blocked, right? So if you have, I know that some companies are sort of experimenting with using artificial intelligence, machine learning for API security. That can backfire, right? Because you can potentially get that mechanism, that tool, block some traffic because it doesn't look to the product, to that machine learning algorithm. It looks like anomalous, but then you would get your subscribers, your partners calling you, asking what's the problem, and you would not be able to explain that to them. So you look for that explainability, that reporting, monitoring side that would have specific rules and that you can use to explain to your subscribers.
In final question, Dmitry, what do you say to CISOs who are concerned about availability of their API by deploying something like this in front of their API source? Because if you think about it, and much to your point, the API is really the center of gravity for the business. Right? I mean, a lot of organizations now are no longer this sort of castle and moat security architecture. You know, we're looking at zero trust security models and things like that. I'm sure, you know, uptime and availability is the most paramount thing on the front of the minds of every CISO out there. What do you say to CISOs who are concerned about how disruptive an API security solution might be to the availability of their API servers? What do you typically tell them?
Right. So absolutely. So APIs are obviously under other backend of the businesses these days. So availability is key. I think a few things to look at is obviously whenever you are using third-party solution, look at the scenarios on how you depend on that solution, especially at runtime, and be able to look at the two different, at the runtime scenario versus development scenario, right? If you're using an external solution for just API development and sort of security at the development stage, then yes, if it goes offline, if that external partner is not available, it's okay. Maybe your developers will have to wait, 5 minutes, 10 minutes, an hour for that service to come back. So it might impact developer productivity, but it won't impact the business. The runtime is obviously something that can affect the business, right? So then look at how you're using that technology. Is it some sort of a gateway hosted by that vendor somewhere in their cloud? Then if that gateway goes down, then your traffic would not be able to get to your backend.
Right.
And so what's your plan B? Or would you be able to redirect the traffic back? In our case, we actually encourage people to use our API firewall locally, within their own, as a sidecar, ideally as a sidecar deployment model within the pods running their microservices. So it's all local deployment. There's no network overhead and there's no dependency on our cloud. The whole enforcement is happening locally. So we would highly encourage that scenario.
Sure. Yeah. And so you guys deliver your product both as a software as a service in the cloud, I'm assuming using Amazon or something. And you also have an on-prem solution.
Yes. So the preferred scenario for us is cloud being used for administration and for security assessments, for the audits, for the scanning. But then for the actual enforcement, for the runtime, you use local deployments, that local API firewalls. Local being meaning within the same deployment as your actual backend. It might be local or it might be in some other cloud for you. And then another aspect of the availability that you mentioned is just the automation within the whole process of API lifecycle and API changes, right? So because APIs, again, these days, they are no longer static. Companies have hundreds, if not thousands, of APIs and microservices.
Right.
Developers keep working on them. Developers keep changing them.
Wow.
So make sure that the product you pick can get integrated within your developer workflows, your developer pipeline. And when a developer changes an API and that change goes into production, your security product enforces security, and the new policy goes into production automatically. So you don't have someone who would actually need to go and manually tweak the rules and tweak the policies based on each and every change coming from the developer. Because if there's a manual step, then that would definitely affect your availability.
Yeah, that makes a lot of sense. So I think we've given CISOs a lot to think about as it relates to deploying these, how they work, why they need it. So the who, what, where, when, why. I guess the final question is you guys are developing some very cool tech over there. How can CISOs reach you? How can they request? Can they request a demo of 42 Crunch and play with it in their environment before they decide to purchase? How can they reach you and how can they take a look at your product?
Okay, so the shameless plug time. So yes.
Shameless plug, yes.
So yes, by all means, go to 42crunch.com, click the request demo, request access button, fill out the form. We'll provision an account for you, or we'll give you a demo. Our account manager will happily get on the call and give a demo. We'll give you an account so you can, again, we have that cloud deployment that you can use for your evaluation. And by all means, security products need to be seen and tried before you start using them.
What I love about your product is you started the show out with this is just moving left. It's trying to weave security hygiene into the fabric of the development itself, trying to get away from this whole mentality of testing and fixing after it's deployed, but trying to actually get it into the mindset of the developers in the ADE. And that's what I really like about your product is, hey, you know what? We're not going to put a product out there on the market that just addresses post-deployment security issues where it's interdicting traffic and trying to prevent the attack. We're trying to actually eliminate the vulnerabilities completely. We've thought about it from cradle to grave. We've thought about everything from the initial code development to the post-production deployment.
Yeah, absolutely. APIs are in the heart of your applications and your data access. So they need to be, security needs to be enforced on all the stages, on the design, on the implementation, and obviously on the runtime stage. All of them are important.
I think the news headlines recently about APIs getting hacked, even Facebook's, there is no shortage of empirical data here on the threat to APIs. I think it's only going to get worse before it gets better. I do. I really believe that we have not seen the end of this. I think this is a new attack surface for hackers. I think hackers are now wrapping their heads around this and the new soft GUI attack surface and APIs. And I think it's going to continue to get worse until it gets better. So I'm really glad that you guys exist. I'm really glad that you guys are around to help swoop in and save the day. For our listeners who want to know more about the technology, the plumbing of it, so to speak, I will be doing a research report into 42 Crunch. This is what I'm focusing on this month in May. So expect me, vendors, expect research to come out. I definitely am very intoxicated by what is happening at 42 Crunch and what they've brought to market. And I look forward to researching it and educating the market on it and what it's doing. So, Dmitry, it has been a real pleasure having you on the show. I'm really nerding out on what you guys are doing, and it's been fun getting to know you and the product. And I look forward to spending the next month with you and the technology and getting the word out and being the voice on what exactly it does and why people need it.
Yeah, glad to be here. Thanks, Alyssa.
Thank you, Dmitry. Oh, by the way, can people reach out to you? Are you on Twitter? Can they follow you on Twitter? Can they? Do you have LinkedIn that you want to share with anyone as far as social networking is concerned? If they want to follow 42 Crunch or you?
Yes. So I'm on Twitter, Sotnikov, and also we have our APIsecurity.io community site and a Twitter account, APIsecurity.io, that has daily news on API security and the weekly newsletter. So by all means, subscribe to that, use that, and send us your questions, concerns, news, and so on.
Yeah, I'm glad you brought that up. I love the community you guys are creating with that site, and I think it's great. I think we need more of that. The more light and education we can put out there on this problem is great, and I'm glad you guys are spearheading that effort. So thanks for championing that.
Yeah, absolutely. And obviously that the community side, it has not just our 42 Crunch news, it has news from the whole spectrum of other vendors and other researchers and analysts and so on. So by all means, use that. And if you're on the vendor, analyst, media side, please reach out and contribute to that.
Definitely. And sorry, the URL again is apisecurity.io, correct?
Yes, that's correct.
Awesome. All right, Dmitry, thanks again. And I'd love to actually have you back on the show. This has been great. And I love the discourse around API security and these discussions. So let's definitely have you back on in a future episode.
Absolutely. By all means.
Thanks, Dmitry. Bye-bye.
Thanks. Bye.